Hi, Mrs. Jacobs here, physics teacher at Naperville North High School, here to do a tutorial on how to solve an unbalanced forces problem. Now, in any unbalanced forces problem, we're going to follow these steps and process because they will help us solve the problem no matter what it is they ask us to solve for. So first, we're going to draw a picture of the situation, just a rough sketch, understand what's going on, draw a free body diagram for the object with labeled forces, write the net force equation from the free body diagram. If it's vertical, I'm going to do up minus down. If it's horizontal, I'm going to do right minus left. And then solve for any unknowns that I can. At some point, I will always be using my net force equation from the free body diagram. And at some point, I will always be using F net equals mass times acceleration, which is Newton's second law. These are multi-step problems, so following this process will really help you keep track of what you know and what you don't know yet. Okay, problem one. I have a 90 kilogram man moving downward in an elevator. His mass is 90 kilograms and he's moving down. His normal force is 120 newtons. Okay, so that's kind of step one. I drew my picture and I listed out what I knew. Now I'm going to draw a free body diagram for the man. I always start with FG on the man by the earth. And then the only thing that's touching him is the floor of the elevator, and that provides a normal force. On the man by the elevator. This force is 1,120 newtons because it was given. I'm going to write out my net force equation. This is a vertical situation. So it's Fn minus Fg. At some point, I'll be using that in the solution. And I'm also going to write out Newton's second law, F net equals mass times acceleration, because at some point I will be using that equation. The other thing I can always write out is the force of gravity equation. 9.8 newtons per kilogram times mass. If I know the mass, I should start off by solving for Fg. That's always a good first step. So 90 times 9.8 is 882 newtons is the force of gravity. And I like to label it right on my diagram. Now in this problem, I'm going to start with this side of the net force equation because I know normal force and I know the force of gravity right now. So I'm going to plug in my normal force. And I'm going to subtract 882 newtons. And I get net force equals 238 newtons. So in this case, the normal force was greater than the force of gravity. And again, I do want to see this written out before we just plug numbers in. That's important to me. Now, going one step further, if I want the acceleration, I now know the net force. I can plug that in. So that kind of unlocked the door to this equation. I do know the mass. It is not the force of gravity. It is the 90 kilograms times acceleration. The acceleration, I'm going to divide both sides by 90 kilograms. And the answer is 2.64 meters per second. That's actually what they asked me to solve for. What is his acceleration? So I had to do many steps to get there. The last question is a conceptual question. Is he speeding up or slowing down? Well, it said he was moving downwards in the elevator. His velocity was down. But his net force was up since his normal force was greater than Fg. So because they're in opposite directions, he is slowing down. And I know that because velocity is down and net force is opposite. Okay, let's do one more problem. That was a good vertical problem. Let's try a horizontal problem. A 55 kilogram crate is being pushed to the left across the floor with a force of 150 newtons by a student. Here's my 55 kilogram crate, and they are applying the force of 150 newtons to the left. Also know that the force of friction is 70 newtons. Okay. Gonna draw my force of gravity on the crate by the earth, on the crate by the floor, normal force. In this case, those two forces are equal. Because this is a horizontal situation, the two vertical forces are balanced. An applied force on the crate by the student, that was 150 newtons. And my force of friction on the crate by the floor is 70 newtons. I've got my picture, my free body diagram. Next up, I'm going to write net force. I like to write right minus left for a horizontal situation. So I'm going to do friction minus apply. And I'm going to do F net equals MA. So in this case, I could solve it for the force of gravity. But since this is a horizontal situation, I don't actually have FG in any of my equations. I'm just going to leave it alone. That's okay. I am going to subtract the two horizontal forces. The force of friction was 70 newtons. The applied force was 150 newtons. So when I subtract them, I get negative 80 newtons. Okay. And I do get a negative answer, and that's fine. I like that because it just means that the left-hand force is greater than the right-hand force. Now, it says, what is the acceleration of the crate? I have to go one more step. I have to use Newton's second law. I know the net force. I know the mass. I don't know the acceleration. So I'm going to divide both sides by 55 kilograms. And I got accelerations negative 1.45 meters per second per second. A Newton divided by kilogram is a meter per second per second. Is the crate speeding up or slowing down? The velocity is to the left because that's the way the crate is moving. The motion is to the left. The net force is to the left. So this is a case where we're speeding up because net force and velocity are in the same direction. Okay. I would suggest continuing on and watching part 2 tutorial where I solve, instead of solving for acceleration, I give acceleration in those problems and I ask you to solve for an individual force on the free body diagram. But hopefully this was helpful. Just a couple steps and a couple examples of unbalanced forces problems.